Everyone, we will solve this today's LeetCode problem. This is LeetCode hard. The question is IPO, right? So let's see what the question is asking. So here, suppose LeetCode will start its IPO soon. In order to sell a good price of its shares to venture capital, LeetCode would like to work on some projects to increase its capital before the IPO. Blah blah blah. And since it has a limited resources, it can only finishes at most k distinct projects before the IPO. Okay, the main question started from here, right? So it can only finish at most k distinct projects before the IPO. Help LeetCode design the best way to maximize its total capital after finishing at most k distinct projects. And we have given n projects where the ith project has pure profit I, and a minimum capital I is needed to start it. Initially you have w capital. When you finish a project, you will obtain its pure profit, and the profit will add it to your capital. Pick a list of most k distinct projects from given projects to maximize your final capital and return the final maximized capital. Okay, so the question, mainly the question is asking that we can at most we can at most take k projects, right? And and the capital is needed, minimum capital. This capital is minimum to start a project, and a is assigned profit is given for that particular project, right? That particular project to after completion, of course, right? After completion, right? This is the mainly question. So the question now is simply that we need to choose k distinct we need to choose in this profit k possible elements, so that I can maximize my wealth. I can maximize my capital after after taking this profit, right? After taking this profit. So the question is simply is we need to choose k k elements from the projects from this k projects from the n projects, right? And maximize the at most k. We can choose less than k also. At most means less than equals to k, right? Not more than k, right? At most k projects from n projects and maximize the capital, right? This is the mainly question. Okay, right? So if the one thing which came in my mind, that I will choose a particular project and uh, check that whether this capital is greater than whether this capital is less than my w. So what the deduction can you tell that I will choose only that projects which has less than capital I, which with my current wealth, right? This is the current wealth. This is the sure. The current wealth should be, which is w, should be greater than capital I. Then I will choose that project. Simple. Second, the profit which I get, the profit I will get, profit should be also greater than this capital I. This must be also condition. This two, the condition should be also there. And at most, at most, I can choose k projects, right? These three things are definitely there, right? I can think of these three, right? Okay, so the thing is, we have we have an options, right? We have an option of taking take and not take of a particular project on the basis of on the basis of these three conditions, on the basis of these three conditions, right? On these three conditions. But if we see constraints here, if we see constraints here, k is given 10 to the power 5, w is given 10 to the power 9, and n is given 10 to the power 5. So if we have conditions take on these approaches, so this total depends, it totally depends on k and w, right? And here the constraints is very high, right? So we can't do this we can't do we can't do this in O of n into k, right? For sure. Either I need to do it in O of n or maximum or O of n log n, right? This is the sure shot. I am confirmed that either I can do it in O of n log n, because n into k is not able to, I cannot do in O of n into k. Otherwise, what I will do, I will take that which current wealth is greater than this capital, and I will choose the whole of the elements, and again I will choose take and not take to till the k projects I can choose, right? And we will take the maximum of that. So I'm sure of that, right? So uh, okay, now how will I do it in O of n or O of n log n, right? So the thing is, these three conditions should be fulfill anytime, right? So okay, if I see examples, like if I take example of profit in it, any profit, this will be 1 2 5 6, let's take at 6, and this would be 4, right? And I take a capital to start these projects is like, let's take as a 1 2 1 3 2, right? This would be the capital to start this project. Now if I need to maximize I need to maximize it, right? Definitely I need to maximize it, maximize the profit. So for that I can, and w is given, let's take w is 1 given, and I can choose at most k is equals to 3, right? I can choose k is equals to 3. So for this one, which projects can I start? I can start this one, right? So this is at 0th, so I can start this is at 2. I can start, no I cannot start. So between 0 and 2, which which profit I will choose, because this one and this one is sure short I can take. So between these, this 5 profit is maximum, right? This 5 profit is maximum. It means, what does it mean? It means I can take this 5 as in my answer, right? So I will take this 5 as in my answer, in my wealth, right? In my wealth, this is initial position. After taking this wealth, I will take 5 and it will become 6, right? Now this 0 and 2, I have already taken 0 and 2, which is given me this 5 and 6, right? And this the second position is already been taken, which is 5, so I will remove that, right? Now again, this 6, this 6, how many capitals I can how many projects I can start? I can start this, because this is already taken. So I can start all of the projects. So I will insert all of them, 0 1 3 4, right? All of that. Again, what are the maximum I can take between 0 1 3 and 4? 0 1 3 and 4, which is 6, of course. So I will take again 6, that would give us 12. Now any any is left, anyone is left? No, anyone is not left to chase that, right? So it means I have left with k2, because I have already chosen two projects, and k is still left with 1. Means I can choose one project also. So between 0 3 4, which is the maximum? 0 3 and 4. 4 is the maximum, so I can take 4 also. So answer is 16. Answer is 16. And if you see, randomly, this w1 I can take 5, then it becomes 2, then I can 6, and this 6 plus 2 is 8. So 8 plus 4, no sorry, yeah, yeah, 6 5 and 4, which is 6 4 10, 10 plus 5 15, 15 plus 1 is 16. So the maximum profit is 16 I can take, right? Because here is given that I will take pure profits, I with minimum capital of needed to start it. It means I don't need to spend that one with this, right? This is the 16 of this answer will come, right? So one thing is clear, that I need to take the maximum. So for taking maximum among all the projects, any data structure comes in your mind. Any data structure comes in your mind, right? Any data comes to your mind. Yes, max heap. Max heap. It gives us the max value at top position, right? It gives the max position at the top value. So we will use priority queue for that. But the thing is how we will choose the projects and take out the maximum. Now the problem is that how we will choose, because for checking that which projects need to choose, I need to trade. How will I trade in this capital? If I trade again and again in this capital, that will we take over fine into k. That is also not optimal. So for that one thing is, you will see one thing that I can take the help of shorting. I can take the help of shorting. How? Suppose I have shorted this capital, which is given further 1 1 2 2 3. So this should be the profit should also be shorted in this order. So I will short this again in that order, right? So that would be again, this 1 1 is again 1 and 5, right? This would be 1, this would be 5, this will be 2 and 2, which is 4 and 6, and this is 3, which is 2, right? So this is the order of after shorting. After shorting, so how that will help? So suppose if I have given w initial with 1, so I can definitely choose from the starting point. I don't need to choose iterate in whole of the capital to take that which is greater than this w1. If I started from initial, I will check that w is greater than capital I, so I can take 1 as a profit, right? Again I can take 5 as a profit, right? Right. And if I take 1 and 5, so w is, and this is 2, which is greater than this w, I can't take this. So it means from here to here I don't need to traverse again. I will traverse this again till this here only. So from this 1 and 5, which is the maximum, so this value is inserted in priority queue to extract the maximum profit from here. So this 5 can be taken out from here, right? So this becomes 6. Now this 5 should be removed because we have already taken that profit. Now the thing is, we have already iterated till this 1th part, right? So till this. Now for checking which projects can be started from this current wealth, I can start from this here, this 2 part, right? So this 6 is greater than 2, this is greater than 2, this is 3, so I can take this whole profit. So I will insert this 4, this 6 and 2, right? And also the k was given, what was the k, is 3, right? So after taking this 6, I will decrease this to 2, and and among these now 1462, which is the maximum 6, so I will again add 6 and take that profit, right? And this will become 1. Now this 6 should be removed from here also because I have taken that. Now this 1 is is still left, and it means I can take one project also. Among this, which is the maximum? 4 is the maximum, so I can take this 4 also. So that would give us 16, and this 4 is removed. Now this k becomes 0, it means I can't choose any of the projects now. So this 1 and 2 will be not chosen, it is left out, right? So our answer is 16. Our answer is 16. So the sorting helps us to choose the number of projects by seeing the wealth, right? And priority queue helps us to determine the chosen profit between the chosen projects, right? So this question is now simple, become simple. This question is now become simple, become simple. The first thing which we'll do, we will make pair of capital and profit and short it according to capital. Then we will we will choose the projects, which is less than, which is the less than the current element, right? Less than equals to the current element. And what we will do, we will take the max profit among the max profit among the chosen projects chosen projects until when chosen projects until which till when we will do that till and we will do this till we will do this till I till I get at most k projects or 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 the number of projects is number of projects is number of projects is over, right? So this would be the approach, simply approach, right? So you see that this question is hard, right? This question is hard, but from analyzation purpose, from choosing from thinking of DP approach to an login approach and using priority queue as an option, we get this approach, right? And the shorting and all. So this is how you think for any of the questions, right? So why will not take in the DP approach? Because the constraints are very long. So it means I got an idea that I will definitely can't do in DP and O of n into k, and the brute force won't work. So I can either do it in O of n and unlog n. So I think in that direction, that how can I do that. So the second thought I comes in my mind, that I need to take a maximized profit. So for calculating the maximum profit, what data structures I can use. I can use a max heap, I can use a shorting, reverse shorting, right? That's the whole structure I do. So the thing is that's how you think of any approaches, right? Again, when I choose max heap, so the second problem I was facing, that I need to choose the projects, but for choosing the projects I need to iterating in whole of capital, that right? So for not doing that, what I can do, I can choose sorting, right? So that's how you analyze the problems and see. This is a hard question, but this becomes an easy one, right? So let's try to implement this. You will be better understand. If you have any doubt, uh, you will get your answer in the implementation part. So suppose so first thing what we need to do, we need to make pair of capitals and profit. So we will make a pair of capital and profit. So for that, the first thing is v. In Python, you can make a tuple, right? You can make tuples in Python, right? Now I will iterate in the projects, and what I will do, I will just simply take the capital and profit. Simple, right? Now what I will do, I will short it according to the capital. So I will just short it. So the reason why I have taken the capital I in the first part, because when I do this v dot begin to v dots end, this will automatically sort according to the first value. But when we need to sort it according to the second value, I need to make a comparator function, right? So here I have inserted this in at the first position. This will be automatically sorted according to the capital I, right? So I don't need to comparator function here, right? Now this is sorted in increasing order. Now what I will do, I need to take a help of priority queue. So I will take a help of priority queue, which is a maxip again, which is a maxip, right? Now the thing is, I can choose at most k projects, right? So if k projects is chosen, I will not take any of this. So I will choose, I can take at most k projects, right? And k is given at is 1, right? So I can do this while k minus 1 is, right? Now the first thing is, I need to choose projects. So how can I choose projects? I will choose projects if w is greater than capital I. So if this w is greater than any of the capital I will choose that. So for that I need to iterate in that. So what I will do, I will just iterate. I will just iterate less than n, and this would be. And what I will check, I will check that if w is greater than this current capital I or this vi dot first, because the capital I is at first position. If it is greater than, I will insert what I will insert this profit part, because I need to maximize the profit. So I will insert the profit. I will insert the profit and increment the this I part. So this will insert all the projects which I can choose with the current wealth, right? I can choose with the current wealth. So I need to also initialize this I value to 0, right? Now after this I need to take the maximum of the inserted profits. So for that, what I will do, I will just take the top position, because heap will give us the max heap, right? And I will pop the data element which a profit which I have taken already. So this will be added in my current wealth, so that I can choose use it in my further implementation, further part, right? So this is the whole approach, and I will just simply return the W, which is the overall wealth after choosing k projects, right? So suppose here we have handled all the cases. How? See, this k, if the k is over before this, so this will end it, right? If this I is over, it means it will take only the okay, if is what is I is over and pq is empty, right? So this will give an error. So for that I need to check that if my priority key is empty. If my priority key is empty, it means I don't left with any of the projects I can take, right? I don't left any of the projects. It means I can just simply return W from here, or you can just break whatever you want. Either you can return from here, or you can break it, right? The simple thing. If any of the capital I is any of the capital I is not less than equals to this current wealth, it means we have don't have left with any of the elements in my priority queue. So I need to check that, right? So this would be the approach. Let's try to run this, and I think I have not missed any edge cases. Oh, okay, this should be the profits, and this should be also profits, and anything else. I don't think so. Let's run this again. uh, this is past sample case. Let's submit it. Yeah, we have passed all the cases, right? So this is the new feature of analyze complexity. If you uh, submission length exceeded, okay. I don't know what is does it mean, right? So no problem. This is O of so we will analyze time complexity by your own, by us, by own, right? So if we analyze the time complexity, if we analyze the time complexity, so what is the time complexity for that? So done we have done sorting of what, this profits and capital on the basis of capital. That would definitely take O of n log n, right? That would definitely take O of n log n. Now for each and every for each and every for each and every projects, I have chosen to insert in a priority queue. So but if you see here that I am inserting only one time. I am inserting only one time. See, this I is less than n and W is greater than Vi dot first. So this I is always increasing. It is never decreasing, or I am not going anywhere else. It is always increasing. It means I am taking only the one time in my priority queue. So for each insertion, it takes O of log n, and there are total n elements. So that would be O of n log n, right? For each insertion, it takes log of n, the number of elements, and their total n elements. So that would be O of n log n for priority queue, right? And for this while k, so this is the iteration till k projects. So it will be the iteration till k projects. It means if I have already taken this k part, so this will be over, right? So it will be O of k in the worst worst, in the worst part. It will take O of k, right? At worst it can take O of k definitely, right? So that would be over of O of n log n. If you see this, because this k and n is tends to per 5. So at the worst, over time complexity would be O of n log n. and the space complexity would be, so the space complexity would be, we have taken an extra vector for that, so for insertion this, and also a priority queue for taking that, so that would O of n and O of n also, so that would be O of n. So this is how we solve this problem with using priority queue. Hope you liked it and understand the whole analyzation approaches. Thank you so much. Bye bye.